secret of my success has been asking why, and then daring to ask why not, and to be unafraid of failure and just keep moving on and asking why all the time. Why is it that way? Why does it need to be that way? Why can't it be a different way? And really seeking better. When I was a kid growing up, my first thought was I wanted to be an architect. And that kind of grew out of, I think, building cities in my sandbox and playing with my Matchbox cars and trying to create and then destroy and recreate new creations. And about the time I was in middle school, I got to watch the Sears Tower get built in Chicago. I lived just outside of Chicago and got to see that building go up, and it was truly amazing to me. And I thought, wow, that'd be really cool to design and work on these tall buildings. Turns out that I have two uncles that are both civil engineers. And around 8th or 9th grade, they sat me down and explained to me the difference between what an architect does and what an engineer does. And it was pretty clear at that moment that I was far more comfortable working with math and science and very kind of technically minded, and my artistic abilities were poor. So I started down the path of engineering probably in high school and never looked back, just kept going, and it's been quite the amazing journey. Very happy about it. So I grew up in the Midwest, kind of a blue-collar family. And as a kid, what was popular music for me was hard rock. And so one of my favorite bands growing up was Rush. And one of the anthems of Rush is a song called Working Man. That would be it. I don't know that I have a favorite quote. I have lots of quotes that I have posted all throughout my office, actually. The one that comes to my mind at this particular moment is an often misquoted statement that was made by Winston Churchill in World War II. And it's often said that he said, never give up. He actually said, never give in. So SpeedCore is the evolution of some thinking that started 20 or 25 years ago. And as structural systems have evolved for the design of tall buildings, so our thinking has tried to kind of be ahead of that evolution, mostly responding to what our clients are demanding in efficiency and cost effectiveness. And so SpeedCore is just the next step along that path. The primary target of SpeedCore was to eliminate the time delay in constructing a reinforced concrete core as it related to erecting the steel around it. We'd witnessed that on dozens and dozens of projects over the last 20 years. And so the idea was to try and squeeze that out of the schedule, and that got us to SpeedCore. Right, so SpeedCore has captured the imagination and interest of lots of people around the country. Everybody seeking to go faster. What has proven to be a little friction in the system is just change. People are afraid of change, whether it be labor unions that are afraid of losing their body of work, whether it be general contractors who are a little reticent of trying something new, or owners who are skittish about the risks of something new. So that's really been the friction in the system. It's not so much been the technology, it's really the apprehension about change. And so in time, after we build 2 or 3 or 4 or 10 more of these, I think the momentum will gain rapidly. But so far only one, number 2's on the way. So there are a number of innovations that we're working on currently for the future of steel buildings. A few in particular come to mind. One is developing SpeedFloor to go along with SpeedCore. And the idea is to modularize, panelize, prefabricate large portions of building floors, primarily for office buildings, with again the goal to go faster. And so that work is underway, ongoing. We're also spending a great deal of effort in the world of fire engineering, performance-based fire design, and the ability to remove spray-on fireproofing from structures in a kind of thoughtful engineering or engineered sense is another area. And then perhaps finally, wind engineering has come to the top of the list, where we've spent the last couple of decades working on performance-based seismic design. We're shifting now to performance-based wind design, where we're going to allow some modest nonlinearity in our buildings as they absorb the energy from huge windstorms. And that will result in our ability to design more efficiently and in fact build buildings more quickly.